So the radar works by sending out radio waves, sends out pulses of radio waves, and as these travel through the atmosphere, they reflect off targets. So you can think of it as though if you were throwing a tennis ball against the wall, it would hit the wall and come back to you. So these radio waves propagate out through the atmosphere and they reflect off targets. And the targets that we're interested in are precipitation, so raindrops, snowflakes, hailstones. So if you've got a rain shower, the more drops there are and the larger the raindrops there are, the more signal will get reflected back to the radar. So the radar can tell how heavy the rain is and also where it's located. A key aspect of our radar is that it has dual polarization capability. And this means that instead of just sending out one beam of radio waves, we actually send out two, perpendicular to each other. So we send out radio waves with a horizontal polarization and then one with vertical. And what we do is we look at the ratio between the horizontal and the vertical. And depending on the type of particle, if it has a larger horizontal dimension than vertical, it will reflect more radiation in the horizontal than the vertical. So we compare these two signals and we can tell what type of particles we're looking at. So for example, a raindrop, a large raindrop, tends to fall quite obliquely, quite flat. So it's not the shape of a teardrop, as most people expect with raindrops. They're actually spherical when they're small, or as they get bigger, they become more oblate. Then on the other hand, for example, a snowflake is quite similar in its horizontal and vertical dimensions. So that will give a different signal back to the radar. So the radar is able to use this technique in order to deduce what type of particles we have in a cloud. And then we can tell a lot more about what's going on inside a cloud.